In this lecture, we'll see in great detail how a bid is placed. When somebody wants to place a bid, a function named placedBid will be called. This function will be a payable function because the user sends Ether while calling this function. So let's create a function named placedBid. By the way, this is the main function of our auction. This function must be payable. Then we have some requirements. For example, we don't allow the owner to bid because it is in his interest to artificially increase the highest binding bid. So the owner is not allowed to bid. I'll create a function modifier not owner. So not owner require msg.sender is not equal to the owner. So here I'll write not owner. A bid can be placed only if the placement time is between the start and the end time. So I'll create another modifier called after start, and I require that block.number, so the current block must be greater than or equal to start block, our state variable. And another modifier before end. Require block.number, so the current block must be less than or equal to end block. Okay, here I write these modifiers, so after start, before end. My function will run only if these three constraints are satisfied. And I also want this function to return a Boolean value of true or false. True if the bid has been placed successfully, and false otherwise. So returns bool. Inside this function, I require that the auction must be in the running state, so require auction state is equal to state.running. And I also require a minimum value that can be sent. I don't want to allow somebody to send 0 Ether or one way. So require msg.value, the value sent to my contract is greater than, let's say, 0.001 Ether. Okay, I forgot one thing. Here I must write underline and a semicolon. And our function is public. So this is a public function. It can be called from an external application. Before continuing our function, I must be sure that you understand in detail what happens when somebody places a bid. So let's go here. We suppose we have two bidders. So this is my mapping variable, the bids variable. The keys are the addresses that sent Ether, and this is the sent value. Our bid increment is 10, and the highest bidder is this address that starts with ABC, and the highest binding bid is 50. Why 50? Because we have this bid increment. So the application automatically bids in increments of 10. This is our contract state at a specific time. And now let's suppose that this bidder wants to outbid the other bidder. So this address, this account, this one, sends 15 Ether or 15 way. What happens? First, the value associated with this key, with his address key. So bids of 0x123 equals the previous value 40 plus 15 equals 55. And then the highest binding bid. What is the highest binding bid? Okay, we can see very easily that the highest binding bid is 65. Yeah, 65. Why 65? Because the other bidder has already bid 70. So the highest bidder will be the other address, the address that starts with ABC. So in fact, the highest binding bid will be the minimum value of the current bid, the new bid of 55, plus the increment and the value of the highest bidder. So this is 70 here, and this is 65. This is the highest binding bid. So if our auction stops right away, this is the selling price. The selling price won't be 70 because that is not necessary. The selling price is 65. This is the purpose of this bid increment. Let's return to our smart contract. So here I take the current bid. So unsigned integer current bid equals the existing bid. This is bids of msg.sender. So his existing bid. If there is no bid, this value is 0. So there is no problem if this is the first bid of our user, plus the current bid. The current bid, the current value is in the variable msg.value. Yeah, let's return here. This is the operation. The current bid is the existing bid plus the new value. I must tell you that this is somehow a little bit strange. For example, if I go to eBay and I bid, let's say $80, and somebody outbids me and I want to bid $10 more, I don't bid $10, I'll bid 90 or 100. So every time someone bids on eBay or on another platform, he bids with the entire amount. Here, the contract logic is different from the front-end logic. If somebody has already bid 50 and wants to bid another 20, he'll bid 20 and not 70, but the total bid will be 70. So this is the current bid. I have a requirement. What if the user, instead of bidding 35, bids only, let's say, 5? So here we have 40 plus 5 equals 45. This value is less than 50, the highest binding bid. The place bid function stops. And there is nothing for us to do. So it is a requirement that this value from here must be greater than this value. Back here, we require that current bid is greater than highest binding bid. And now we update the value from our mapping variable. So bids of msg.sender is equal to current bid. Back to our slide, let's write down the old values. So 15 and 55. Here we have two possibilities. When the current bid, this value, is greater than the highest binding bid, but is less than the value sent by the highest bidder, is less than this value. So here I write if current bid is less than or equal to bids of highest bidder. So this is the case. this value is less than this value. Anyway, this value is greater than this value. I have this requirement here. What do I do now? I'll calculate the highest binding bid, being this value, and the highest bidder remains the same. So here I write something like this: highest binding bid equals mean from minimum of current bid plus bid increment and bids of highest bidder. We have a very small problem. Solidity doesn't offer a function that returns the minimum of two numbers. So I must create this function by myself. I'll create another function named mean. This function receives two arguments. Let's say uint a, uint b. And here we have something new. When a function doesn't touch the blockchain, that means doesn't read from the blockchain and doesn't write to the blockchain, we can define that function as pure. This function is an internal function, is a helper function that can be run or will be run only from inside this contract, and my function will return an unsigned integer value. And now if a less than equal to b, return a. So what happens if a equals b? If a equals b, I'll return the a. Else, return b. So this is my helper function. Here we have returns. Everything is just fine. There is no error. We continue our place bid function. Here we have an else. So when does this block of code execute? When the current bid is greater than the value sent by the highest bidder. In this case, when this value is greater than this value, when something like this happens, for example, this address sends 100, and here we have 40 plus 100, and here we have 140, something like this. What will be the value of the highest binding bid? If we are looking at this example, we see that the highest binding bid will be 80. Why 80? Because we have this highest value, highest bid from here, plus the increment. So the new highest binding bid, the new selling price will be 80, not 140. The bidder has sent 140 just to be sure that he will win the auction. But he didn't send 140 to buy the product or the service at this price. So here we have a minimum of current bid. So this value, this is the current bid, and this value, so the old value sent by the highest bidder plus the increment. Okay, so here we have highest binding bid equals mean of current bid and bids of highest bidder plus the bid increment. And I also must modify the highest bidder. The highest bidder is a new address. It's the account that has just sent this transaction. So the highest bidder is msg.sender. And if the function gets to this point, here we return true. In the next lecture, we'll test this function to see how it works. See you soon.